All right, so we are going to pick up, we're going to pick up on the back side of the front page. And the reason I went ahead and gave you your worksheet is because we're going to do a couple of those problems as examples, because I didn't feel like your notes had enough examples. So out of everything that we're learning in this packet of notes, I would say today is definitely the most challenging. It's stuff that you haven't done before. It's kind of tedious, but we are going to spend 2 days on it. So we're going to learn and practice today, and then tomorrow is just practicing this some more. All right, so on the back we have this graph of a polynomial. Is somebody's not? Oh, I'm hearing things. Okay, and just a reminder, anytime you write f of x, what are you referring to? The graph? What part of the graph? The y. Good. All right, and then kind of towards the beginning of the year, we talked about where a graph was positive and where a graph was negative. So f of x is greater than 0 or positive means the graph is where? Above the x-axis. Good job. And then less than 0 or negative is going to be below the x-axis. All right. And then, so looking at that graph of f of x, this A part says, where does f of x equal 0? What do you guys think? There's 3 places where it equals 0. Nice job. All right, so the new stuff today is going to be an inequality. So we want to find where f of x is greater than 0. So we're talking about this section right here and this section right here. And we're going to give our answers in interval notation. It's possible that you might need to do, if you want to do, you can do inequality notation, but I think interval is a little bit easier to do that. So anyway, where is the first x where it's greater than 0? -3. Not including, yeah, I see what you mean. All right, and then where does it stop being greater than 0? -1. So we're going to do parentheses so we don't include those numbers because it doesn't have or equal to. Now when we did this before, I'm not sure if I did this u. That u means union, and you're just saying this is multiple intervals where this is true. All right, and then what x do we start being greater than again? 3. And then it goes, this doesn't have a restricted domain. It's going to go forever in both directions. So forever to the right or to infinity, the graph is going to be greater than 0 or positive. All right, for C, we want to give the intervals where f is less than or equal to 0. So you guys try to do that one on your own, please. Do you have,
I'm just going to watch the video.
No, I'll get it. Okay. So why did I do brackets instead of parentheses on this one? Because of the or equal to. So because of the or equal to, you're going to do brackets on it. Okay, so with a graph, that really isn't too bad. But most of these inequalities that we're going to do, you're going to be given in algebraic form, and you won't be able to use a calculator. So we're going to have to do a whole lot of kind of tedious things by hand. None of it is crazy difficult. It's just new, and there's a lot of steps. So the first step is to find when the function equals 0. Sometimes it's in factored form, which is great. Sometimes you might have to factor. So I'm going to talk about the steps as we do the steps on example 4. So the first thing I do is set up a number line. All right, and then we want to find where this equals 0. So how many zeros are there? 3. So I'm going to put 3 little marks on my number line, 1 for each 0. Bless you. And then then we're going to label the zeros on the number line in numerical order. Right, and then sometimes on these zeros you do an open circle and sometimes you do a closed circle. What do you guys think for this one? Someone says open, someone says closed. Open. We're not including where it's 0 because there's not a or equal to bar, so we're going to do open. So if it has an or equal to bar, you do closed. If it doesn't, you do open. All right, so that's kind of step 1 and 2. Step 3 says to test the values in each interval to see if the values in the interval are positive or negative. So this is how I do that. What I do is I just do some little dots to separate this into 4 different regions. All right, and then however many factors you have, then you set up that many little parentheses in each region. So this one has 3 factors. So each region I'll do these 3 little parentheses. And then I'm going to pick an x value in each region. Now, if I pick these numbers, you should get 0 when you plug it in. So I don't want to pick them. I want to pick something on the other side of -4, like -5 to test. Pick something in between -4 and -1. It could be any of those numbers in between -4 and -1. In between -1 and 3. And then on the other side of 3. Right, and so when I plug them in, I'm just going to plug them into each factor individually. And you don't care about what number you get. All you care about is if you get a positive or a negative. So if I take -5 and I put it in for this x, am I going to get a positive or a negative value? -5 minus 3. A negative. So anytime you have a negative and you subtract from it, it's negative. It makes it more negative. It's okay. All right, then I'm going to take -5. I'm going to put it in this set of parentheses for x. So -5 plus 1. Am I going to get a positive or a negative? Negative. Then I'm going to take it and put it here. -5 plus 4. Negative. Okay, then I need to figure out if I do a negative times a negative times another negative, what that's going to be. A negative. So anytime you're multiplying, you have an odd number of negatives, it's going to be a negative. All right, I can do that again for -2 and 0 and 4. So like I said, super tedious. So I'm going to take -2 and I'm going to subtract 3 from it. Is that going to be a positive or a negative? Negative. Then I'm going to take it, -2, and add 1 to it. Still a negative. And then I'm going to take -2, and I'm going to add 4 to it. That bumps it up to positive. So this time if I do a negative times a positive, what am I going to get? Positive. All right, so you guys try 0 and 4. Plug them into the parentheses, seeing if you get a positive or a negative. So what did I want to get for it to be an answer? What do you think? If this was the original problem, I want to get a positive. I want greater than 0. Greater than 0 is positive. So what I would do is I would shade the ones where I got a positive for that region. And those are my solution regions. So I have 2 regions that I would describe using an inequality. So I would go from -4 to -1, and then I would do the u, and then from 3 to infinity. Right? So that's it. That's a lot to do. None of those things are like really, really difficult. It just adds up. All right, so let's look at example 5. All right, so I would always start off with my number line. And then I would find how many zeros there's going to be. What do you guys think? 2. If you count the multiplicity, I guess it's 3, but we just need to find the actual x values. All right, and so we would put them in numerical order on the number line. This one's actually going to be a little bit shorter than the one we just did. We're going to just do our 2 little parentheses. We're going to find a number to test in each region. Don't start doing it yet. There's something I want to talk to you about. So find a number. Now the number line only contains values that are real numbers. And so we don't have to worry about imaginary numbers here. So if I put a real number in for x, added 2 to it, and squared it, would I ever get a negative value? No. So no matter what, when I square that, it's positive. So that's nice. I can just go ahead and that little set of parentheses that represented that factor, I can just make it a positive. I know it's going to be positive. So that works for squares. That works for even powers. Now, if it's a cube, you can't do that. You have to plug in the number. But square, it's nice. So all I have to do on this one is plug these values in here. So remember, anytime you have a negative and I subtract from it, it's definitely a negative. And then a positive times a negative is a negative. All right, 0 minus 5 is going to be a negative. And a positive times a negative is a negative. And then 6 minus 5 is a positive. Okay, so does everybody understand why I automatically put pluses there? Because that will save you some time if you see that. So if your factor is being squared, you can just say it's positive. Okay, what am I looking for? Oh, I forgot to do something. What did I forget to do? I forgot to do dark, closed or open. Am I going to have closed or open? Closed. All right, and then I do want to shade the answer region, and I want negatives this time. And so if that is a closed circle, I can just shade right through it. If it had been open, I would have to stop and then shade on the other side. But how would you describe that answer region? Negative infinity to 5, good. And we would do a bracket because we're including it because there's a closed circle. All right, so that's pretty much it. Sometimes you might have to factor, so I'm going to do one of those on your homework. And then there is one, we're going to do number 9 because something kind of weird happens with the answers. So if you guys will go to your worksheet that I gave you and flip over on the back side, we are going to do number 9 and we're going to do number 14 together. All right, so again, I'm just going to start off with a number line. I'm going to put my zeros on there. Should be 3. All right, and then because the or equal to, we are going to do closed circles. So 3 factors means 3 sets of parentheses in each region. And then I don't know why I put 2. We're going to pick some values for x. Are there any of these parentheses that I can just make positive? Second one, good. Alright, so I'm going to go back and put each test number into x and into x minus 3. So putting it into x is easy. If it's negative, then you get a negative. If you're plugging in a positive, you get a positive. And then remember, a negative minus anything is a negative. And then an even number of negatives when you're multiplying is a positive. All right, same thing. Plug in. Works out exactly the same way. When we plug in 1, it should be a negative once we multiply it all out. And then 4 is all positive. All right, we're looking for where all that stuff multiplied together is going to be, less than or equal to 0. So definitely the negative. And I did this one for a reason, because something a little weird happens with the answer. So is this, actually I'm going to tell you, this is not the only answer. There is another place on this graph where if you multiplied it together, you plug in that number, you would get something that's less than or equal to 0. It's negative 8, yep. So this only happens if it's or equal to. If you have a solid dot floating around, it's part of your answer. Now if it's an open dot floating around, it's not. but the solid dot you do have to include. It's really easy to forget that. Okay, and then we're going to do the very last one because it has some factoring that you have to do, which makes it a little more tedious than the others. Okay, so on 14, I'm going to go over to this side and just factor x squared minus 9. How do you factor that? Good job. It's a difference of squares. Right, and then the other one, we just factor like a regular trinomial where we do x and x. Our signs are different. And then we have to multiply to get 3 and then basically subtract to get 2. Just make sure, because we want that positive 2, we make the 3 be the positive. You could leave it like this if you wanted to. I wouldn't, because that would mean you would have 3 parentheses to test into. So I would go ahead and combine my x plus 3's. All right. So then I have my 3 zeros on my number line. I have my closed circles. Are there any of these that I can automatically make positive? Yeah. The first one should automatically be positive because it's being squared. Okay. And then, I need to write my test values. Alright, so when I'm testing them, I'm going back to the factored. I'm not using this one at all. I'm going back to this one. Alright, so on this one I'm looking for greater than or equal to all those little pluses. And so I'm going to go from negative infinity to 1, and I am going to include 1. And then 3 to infinity, and I'm going to include 3. Alright, so what questions do you guys have?